Hello and welcome to Algebra 1. We're going to start Chapter 7 today with 7.1, and Chapter 7 is called Polynomials. So 7.1 is what we're going to talk about today, and it discusses multiplying monomials. And if you remember from any study of prefixes, that mono means one. So first of all, let's start with the definition of a monomial. It is a number, a variable, or a product of numbers and variables. Then a number by itself, remember, is called a constant. So it can be a number, like 6 is a monomial. It could be a variable, or it could be a product of numbers and variables. And so these would all be monomials. These are three different examples of monomials. What a monomial is not going to have is any addition or subtraction signs, because then you'd have two terms. So each one of these in itself is one term, and that's what makes it a monomial. So we need to decide if these are monomials, and we need to explain our reasoning. So 17 minus s, is that a monomial? So we're going to say no. And what is our reasoning? I would say because it is two terms, not just one term. Or you could say because it has a subtraction sign, or because it is subtraction. So you only need one reason, but there's two there. 8f squared g, is that a monomial? Yes, it is, and that is because it's a product of numbers and variables. That is by definition what makes it a monomial. 3/4, is that a monomial? Yes, it is, because it is a number. Remember, just a number is a monomial. And what about 5 over t? No, that's not, because it's a quotient. And the difference between the third and fourth examples there is that the variable's on the bottom, and so you can't be dividing by a variable. If you had 3/4 t, something like that, yes, that is, because it's a product of a number and a variable, but we can't be dividing by that variable to be a monomial. All right, a little bit of power recall. Remember that something in the form x to the nth power is called a power, represents the product of x times itself, or x as a factor. This is going to be a really key word. Make sure you have that written down. X is a factor in number of times. So if you have 3 squared, that means we're going to take 3 times 3. These are called factors. What we are multiplying together are our factors. Okay? X is the base and n is the exponent. All right, so this isn't exactly on your notes, but this will help us with our first property of exponents, is what does 2 to the 4th mean? So it means 2 times 2 times 2 times 2. Okay, base to an exponent, you take the base times itself as a factor that many times. So if you had 2 to the 4th, so 2 times 2 times 2 times 2 times 2 to the 5th, 2 times 2 times 2 times 2 times 2. So if I have all these 2's, how else could you write that? Well, could I write it 2 to the 9th? Because I have 9 2's. Here's 4 and here's 5, and if I add 4 plus 5, I get 9. And notice from way back up here, if you had done that, you could have gotten straight to that answer. That is our first property of exponent. It is called the product of powers, so product meaning we're multiplying, and at least you need to write down the symbols part, but you're welcome to write down all of it. It says if we are multiplying two powers that have the same base, then we are going to add their exponents. So here we go. We're going to be multiplying. Now when you're multiplying, you're always going to multiply the number parts out front first. So here's 1 and negative 12. So that is going to be a negative 12. And then when we multiply r to the 4th times r to the 7th, our property we just wrote down said we're going to keep our base and we're going to add our exponents And so we get negative 12r to the 11th, and that's our answer. So looking at this next example, go down an example here. You're going to multiply the number parts. So we get 30. Then you're going to look at one base at a time if there's multiple bases. So c, now in any time there's just a variable, it always has an invisible power of 1. So c to the 1 times c to the 5th. When we multiply, you're going to add those exponents and get c to the 6th. And then you're going to look at your d's, d to the 5th times d squared, d to the 7th, because we're going to add those. And then that's your answer. Okay, another little exploration. So if I have 4 squared to the 5th, what does that mean? Well, that means I'm going to have 4 squared times 4 squared times 4 squared times 4 squared times 4 squared, which means I have 4 times 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 4. And how can I write that? Well, there's 2, 4, 6, 8, there's 10 4s, so that would be 4 to the 10th. So is there any way I can go from here to there? I can multiply those exponents. Okay, and we're going to skip that second part there, but we're going to multiply our exponents, which leads us to power of a power. And this property over and over here says that if you have a power raised to a power, that you multiply them. So you at least need to have this part written down. A to the m to the n equals a to the m times n. So if you have a power to a power, you multiply. You might also write down this example part just as a little reminder of what you need to do. So let's look at these. Are kind of stacked powers here. The first one is 2 cubed, cubed, squared. Okay, we're going to start inside 2 cubed, cubed. That is going to make 2 to the 9th. And then we're going to square that, and that is going to become 2 then to the 18th, because it's still a power to a power. So you get 2 to the 18th. So let's look at this other one. And again, you're following those order of operations, those grouping symbols. We want to start on the inside. So we get 2 squared squared. So it's a power to a power. So we are going to multiply. And then we're going to take that to that other 4th power. And we're going to, because we have a power to a power, multiply one more time. 2 to the 16th. Okay, one more, I think. Power of a product. So what does it mean to have xy to the 4th? We're just going to do this top one here. So this means we're going to have xy times xy times xy times xy. And if we rearrange that, because remember that multiplication is commutative and order doesn't matter, I can make this x times x times x and put all my x's in the front, all my y's in the back, and then I could rewrite this if I wanted to, x to the 4th, y to the 4th. And so see then how I could go from here straight to there. That's what's called power of a product. Okay, so it's taking a product to a power. So if you have a product to a power, what happens is that that power goes to everything in that product. So you at least need to write down that symbol part. You might also write down your example there. And I gave us a little subnote. I would probably write this down as well. If they already have exponents on the inside, then what you do is you have an exponent to an exponent, and you're going to multiply just like your power of a power said a little bit ago. All right, skipping down the page a little bit, we're going to talk about simplifying expressions. So you're going to be asked to simplify expressions involving monomials, and they are simplified when each base appears only once. Now there's no more powers to a power, so you've taken care of all your powers to a power, and all fractions are in the simplest form. So those are your rules for when it is considered simplified. So we're going to look at this here. Now we are multiplying here, but before we can multiply, we kind of probably need to do a little bit of simplifying here and a little bit of simplifying here. So multiple ways you can go about this. And as much as what we were doing earlier, you can, if you want to, start here. That is a power to a power, and that might be an excellent place to start. Keep everything on the inside, and now let's raise it to the fourth power. So let's just work down this left-hand side here. This is now product to a power, and that power on the outside goes to everything. So you're going to have 8 to the fourth, g to the 12th, h to the 16th. Now notice that 8 was to the 1 to begin with, and remember we multiply when you have a power to a power. So if we want to go on to the other side now, that would be 2 to the 4th, because there's a 1 right there, g to the 4th, again because there's a 1 right there, h to the 20th. Okay, so from here, I'm going to, at the moment, just write my numbers out front. I'm going to figure those out here in a minute. Let's combine our g's. We are multiplying, and so what do you do with those exponents? We add them, so g to the 16th, and we're going to have h to the 36th, because we're going to add those together. And then let's go ahead, grab your calculator. And you should have either an X to the Y button in your calculator or a caret button. It looks like that. So we would do 8 and then this caret button and then a 4. So 8 to the 4th, I'm just going to do it over here to the side, is 4,096. 2 to the 4th is 16, so we are multiplying those together. So we are going to get 65,536, g to the 16th, h to the 36th. All right, there we go. That is 7-1. We'll finish the rest of your notes in class. Please let me know if you have questions, and have a great day.